Hello and welcome back to another Siemens S7-1200 and factory I/O tutorial with the Arduino. In this video we will be configuring the Siemens PLC to work as a Modbus client to read the potentiometer's rotational position held in an input register in the Arduino server. So stay tuned. So at the end of the last tutorial video, we had completed the Arduino code and checked that it all worked. Now we're going to start configuring and coding the Modbus client side on the Siemens PLC. Before we start, I'd just like to point out that I've found a lot of the information in the systems manual and will be referring to it to help explain why I'm doing certain things. Anyway, this is where I went for the latest manual and I downloaded it to my PC. So let's make a start. This is where we were at the end of the water tank level control part 2 video. So I'm going to be adding to this program. Firstly, we need to configure the PLC to be able to communicate with other devices. Now, we've already done this in the water tank level control part 2 video at 7 minutes and 50 seconds into the video, as I needed to set up the PLC to talk to factory I/O. However, let's see it again so that these next few videos can be considered Modbus standalone videos. Okay, let's select device configuration. Make sure the PLC is selected and under the General tab, scroll down and select Protection and Security. Then we can scroll down on this side to Connection Mechanisms and we should select Permit Access with Put Get Communication from Remote Partner. As we can see, we've already done that. Okay, let's select the main OB1, go to Network 4 and we'll name it Modbus Arduino PLC. Then on the right hand side under Instructions at the bottom, let's open up the Communication section. Then select Others, Modbus TCP, and then drag over MB Client into Network 4. Let's stick with the default name and select OK. Okay, now we can see the Modbus TCP client DB in Network 4. And if we look under System Blocks, we can see 2 new resources created. Let's close System Blocks up. Okay, now we need to create a new data block to configure how the client will work. So add new data block and we'll call it Modbus config and select OK. Now I'll split the screen so we can see the MB client DB and the Modbus config window. I'll just make better use of the screen space to help explain things a little better. Now I'm going to add all the parameters in the MB client DB into Modbus config DB2 and then come back and configure them as outlined in the system manual, which is section 13.5.2. If we look under Modbus TCP instructions and go to this page here, we can see all the names and data types. Some of the data types I rarely used and I had to look them up to see what they were, but I'm just going to enter them as outlined on this page. So let's start entering. Now the first 2 parameters are rec and disconnect, and they are of data type Boolean. So let's enter them. I'll keep the names the same. Okay, now the next is MB mode. And this data type from the notes is US int. So we'll type in U and select US int from the list. All the data types are explained in section 5.4 of the system manual under data types, and definitely worth a refresher read. Next we have MB data address, and that should be UD int. Okay, then we have MB data length, and that should be U int. We'll miss out MB data PTR for now and come back to it shortly. So let's add connect. Then from the output side, let's add in done. Oh, I forgot to add the data type for connect. Let's have a look at the system manual again. This is a variant, and if we read the description, then we should enter tcon_IP_v4. So let's enter that now. As we enter it, look at what happens at the front of connect. We get a drop-down option for the data type entered. Okay, let's continue with the rest of the client output side. So done is Boolean, and so too are busy and error. And the last parameter is status, and the data type is Word. Okay, let's save what we've done so far, and then let's start entering the start values. Now for rec and disconnect, we'll leave them for the moment and come back to those, and you'll see why. So let's enter the start value for MB mode. If you can remember, the register we need to read in the Arduino is 30,101. And we can see on this page of the manual, this falls in a range of 30,001 to 39,999. Although it describes it as a read input word as opposed to an input register, which may be just a slight change in terminology between Siemens and Arduino. Nevertheless, this is the address we require to read. Therefore, we can see the MB mode as 0, so we're okay on the default for the start value. The MB data address is 30101, as we've already mentioned. So let's enter that, and the MB data length is 1 because we are reading only one register, which will contain the potentiometer value. Next, let's open up Connect, and we need to enter the start value for interface ID. If we look at the system's manual, it actually tells us where we can find this. We go to Device Configuration, then click on the CPU Profinet port image, select the General Properties tab. We also need to select the system constants, but it doesn't actually say that, and we can see the identifier. Anyway, the number is 64, so let's enter that now. Looking at the system manual again, we will choose 1 for the ID. Next, we have the connection type for TCP IP, which is 11 or 0B in hex, so that is okay too. Moving on to active established, this should be 1 or true to initiate MB client Modbus communication. So I'll enter true here. Then we need to open up remote address and enter the IP address for the Arduino, which was set in the Arduino code, and is 192.168.1.120. Then for the last two entries, looking at the system manual, we require 502 for the remote port and 0 if setting up an MB client. So let's enter both of those now. Okay, let's save what we've done so far. So I also need to select retain for connect because this will not change. I'll just close the connect drop down menu so there isn't so much on screen to view. Now we can start entering the parameters in network 4 for the MB DB client. Before we do, we'll just take a look at the system manual again so we can see details of how rec and disconnect work. Now I'm sure there is an efficient way of using these parameters so that we don't continually request information from the server. However, for simplicity, I will set rec to true and disconnect to false continually by using system and clock memory. So we will need to enable those first. We could always go back to this in the future in another video and set these two inputs up more efficiently. So let's bring up the device configuration again and search for system clock memory. Now where is it? Here we go. Okay, select enable and use of system memory byte, and I'll move them to an address I'm not using, say 500. Then come down to clock memory bits and enable those two, and we can start those at 501. Okay, that's great. So let's go back to main OB1, make a little bit more room on screen. And for rec, I'll type AL, then select always true from the drop down. And for disconnect, I'll select always false. Now for the other parameters, we can start bringing down the configuration information. So bring down MB mode and drop it into position on the MB client DB. Then do the same with the rest of the parameters, one by one. Obviously, the only input we can't configure at the moment is the MB data PTR, but we'll come back to that in a moment. So let's continue. The same for the outputs. Okay, now we can have a look at the MB data PTR. So let's look in the system manual and see what it says. So this is the pointer to the Modbus data register. It's basically a buffer, and the important bit is the pointer must assign a non-optimized global DB or an M memory address. So I will use a non-optimized global DB address, and to do that, let's create a DB. So add new block, and we'll call it Modbus PTR, and select OK. We can now see DB3 under Program Blocks, and it's open on the right-hand side of the screen. OK, now we can enter a name for the buffer under Static. So we'll call it simply Data, and we'll make the data type a word. The start value is 0 and it will display in hexadecimal. Now I'll just restore active window layout and then split the screen again so we can see the MB client DB as well. Now we'll just drag data down onto MB data PTR. Now we have to make it a non-optimized global DB, and to do that, right-click on the DB under Program Blocks, select Properties, then untick Optimized Block Access, and select OK to change the block access, and then OK again. Now we're going to download the hardware configuration to the PLC. And when that is complete, we'll download everything. And finish. Now we need to go back to the default window layout. I should have selected the one below, never mind. I can just select main OB1 now, and we can see network 4 with the MB client DB. Now let's go into monitoring mode and run the PLC. I'll just upload the sketch to the Arduino. Oops, I just pressed the reset button on the Arduino before the program was uploaded, so I'd better upload it again. Yep, this time it's okay. I'll minimize the sketch and change the format of the Modbus PTR to decimal from hex. And hopefully everything is working correctly. We can see the potentiometer is at 0. So let's rotate it clockwise, and we see the value going upwards between 0 and 1023. Let's bring up the serial monitor so we can check both the Arduino and PLC values at the same time. I'm just going to make a little bit more room on screen for both windows. And let's turn the potentiometer anti-clockwise. And we can see both windows updating roughly at the same time. Now back up to max 1023 and back down again. I'm happy with that. It all seems to be working. I'll stop the PLC and consider the changes required to the PLC program so that the set point changes as the potentiometer is rotated and the fill valve will open. However, we'll cover that in the next video, so thanks again for watching. Hope you got something useful out of it. If you would like to learn more, then please click the subscribe button and the bell so you'll be informed as soon as a new video is uploaded. Please see the links in the description should you wish to get a free 30-day license of Factory IO, and also check out my Patreon account. And I'll see you in the next video. So bye for now.